All right, look at that. We made it through Unit 2. Moving on to Unit 3. This is Chapter 8, and this whole packet, it's pretty lengthy. It's something like 25 pages. It's just because by the end, there's so much work just for one problem. There's only one problem per page. But this whole document is available in the Canvas modules. It's not required to print it, but it will make things a little bit easier for you so you don't have to write so much. So section 8.1 for today, we're going to work through about the first 5 pages. So that's the first 9 problems of this document. And 8.1 is simplify rational expressions. So rational, that just means a fraction. Okay, so now we're going to take what we learned in the last unit about factoring, and we're going to go ahead and continue that. Okay, so now it's going to be applied to some of these situations you can see here where they're in the fraction, in the rational expression. Okay, so a rational expression, it says, is a fraction, a quotient of 2 polynomials. And I have lots of examples, okay? All those are examples of rational expressions. Before we get into simplifying our own rational expressions, I want to do just a little basic skills review, okay? Just a little bit talking about fractions, because as we work today, you're going to be inclined to kind of make up some of these different rules that don't quite make sense if you think about how fractions work, okay? So let's go ahead and do this little review first. Okay, for this first one, I have 6 over 9. Now, if I wanted to, I could break this apart to 2 times 3 over 3 times 3, right? That would equal 2 over 3 times 3 over 3. 3 over 3 is just 1. So really, we have 6/9 reduces down to 2 over 3. The reason why we're doing it this way is because as we're working with the factoring, we're going to be doing what's called removing a factor of 1. So as you can see here, this 3 over 3 became a 1, right? So this is just a 1. That meant that it canceled out. So you can just put a big 1 right over the top if you want. Okay, the next one, I could rewrite that as 3 times 5 over 8 times 5. Then I could break it apart to get 3/8 is our final answer when we remove that factor of 1 for that 5 over 5. For problem number 3, a little bit different. We have 7 minus 5 all over 5 equals, just subtract, we get 2 over 5. Now the reason why I included this one is because when we get to some polynomials, you're going to try to make up a rule. I'm going to show you the rule that you're going to try to make up, okay? You're going to do this, which is not good. You're going to see the 5 on the top and the 5 on the bottom, and you're going to try to cancel them out. Don't do that, okay? That is not good. Same thing with, once you have the letter in here, like a squared minus 5 over 5, do not cancel the 5s. Okay, I'm going to write that. Okay, because you can see we did 7 minus 5 over 5. It was 2/5. If we would have canceled out the 5s, we would have gotten 7 for our answer. That doesn't make any sense. Okay, so don't try to make up that rule later on today. Okay, don't do it. For the next one, what do we get? Looks like a 6 over 7. What rule do you think somebody's going to try to make up today? They're going to go like this. If it's 4 plus 2 or 4 plus 3, they're going to see the 4 on top, the 4 on the bottom. Okay, again, do not do that. That's not good. So, for example, when we stick in the letter, if you had x plus 2 over x plus 3, that answer would be totally simplified. Do not try to cancel the x's. And finally, 2 times x all over 2, what does that equal? That just equals x. And in this case, we can cancel Because technically, if you're looking at it, 2x over 2, that could really, if we wanted to, we could rewrite that as 2 over 2 times, you could put x over 1, which is just x, would equal, there's that 2 over 2, that's our removing our factor of 1. 2 over 2 is just 1, times that x over 1 is just x, we would get x. Okay, so another way to think of this is if they are separated by addition or subtraction, don't cancel. If it is multiplication, then you can. Okay, so if you're removing that factor, if it's things that are multiplying, you can remove a factor of 1. All right, let's go ahead and turn the page. It says, what numbers make the rational expression undefined? So what does undefined mean in a fraction? So if we have 7 over x, that means 7 divided by something is undefined. Any ideas? Like on your calculator, there's a certain number where if you do 7 divided by that number, it will say error or undefined. It's when x equals 0, right? You cannot have a 0 on the bottom of your fraction. Bad things happen, right? We do not want to have a 0 on the bottom of our fraction. In this case, we also call them excluded values. Okay, so when we're looking at some polynomials with these rational expressions and the denominator is 0, that would be the excluded value. So it makes it so it's undefined. I'm just going to go ahead and write it in when the denominator is 0. So for part 2, determine the excluded values. So I have a minus 8 over a plus 7. Do I even care at all about a minus 8? I really don't. Okay, that can be anything. Who cares? Nothing is going to make that become undefined. What makes it undefined is when the bottom is 0. So what number would make the bottom be 0? That's going to be our excluded value. Some of you can just look at that and you already know the answer, right? You already know what would make that be 0. That's totally fine. You can just write down the answer and be done. If you need to show work, if you want to show work, you would write that denominator set equal to 0, and then you would go ahead and just solve. Okay, so you'd have a plus 7 equals 0, subtract 7 from both sides, and you would get a is equal to negative 7. That means if we had negative 7 for a, that would be an excluded value because it would make the rational expression undefined. Go ahead and try the next two and hit play when you're ready. Okay, for this next one, again, some of you can just look right at it. You know what it is. That's awesome. Some of you might want to write it out, so I'll go ahead and write it. I'm going to have 3a minus 12 is set equal to 0 because I don't care about that a minus 4. All right. Now, I'm going to go ahead and add 12 to both sides. So I have 3a equals 12. And then what do I do next? To get the a by itself, so I'm going to go ahead and divide both sides by that 3. And I get a equals 4. All right, for the next one, again, we don't care about the top, right? We just care about the bottom. So I have x squared minus 3x minus 28. And that one, if you can look at it and know the answer, I'm impressed. Okay, that one we're probably all going to have to show some work on, right? So I'll go ahead and set it equal to 0 to start. Now, the leading coefficient is 1, so I can jump to the shortcut. I need two numbers that multiply to negative 28, but add to negative 3. I'm getting a negative 7 and a positive 4. Okay, that's zero factor property, so we can set each of those equal to 0. And when we solve, we get x equals 7 and x equals -4. So those are our two excluded values. Okay, if you were to plug those back into the denominator, you would get 0 on the bottom. Okay, now let's go ahead and keep working through here. This number 1, you know what, this is the same thing that we just did on the last page. So you can just skip this part, or you can just write it in real quick. It's just that 6 breaks down to 2 times 3 over 3 times 3, which breaks down to 2/3 times 3 over 3. 3 over 3 is 1, giving us that 2/3. Okay. This next one's a little bit different. What do we have going on here? So we're trying to remove a factor of 1, okay? So the first thing I'm going to do to try to make it a little bit easier for us to see is I'm going to break it apart. I'm going to write it as 50 over 40 times the a squared over a times the b over b cubed. Okay, what factor are in both 50 and 40? So I could remove that factor of 1. What would that be? What number over itself would be 1 that would help break this one down? This is going to break down. The factor of 1 is 10 over 10, because 10 is the greatest number that will go into both 50 and 40, leaving me with 5 over the 4, right? So if we do 5 times 10 is 50, 4 times 10 is 40. So we've broken that down where this 10 is really just 1 over 1, right? Or it's just a big 1. So we removed that factor of 1. Now in this next set, what goes into both the top and the bottom? Is there a factor that I can remove? So that factor of 1 is what I'm trying to remove. Both the top and the bottom have the factor of a. So I'm going to put a over a, and what's left over is just an a. I'm going to put a over 1 just so I don't get confused here, because we'd have a squared on the top, a on the bottom. Again, that a over 1, or a over a, is a factor of 1. And then finally, we have b over b cubed. We have b on both the top and the bottom. So there's my factor of 1 is b over b. And multiply that by to get back to the b over b cubed. We already have the b on top, so just 1 over b squared. And one more time, that b over b is removing a factor of 1. So each of those are just 1. So now if we look across the top, what we have left over is 5a over 4b squared. All right. Moving right along, go ahead and turn the page. Number 3, we have 9x plus 15 over 12x plus 20. Okay, so we're trying to remove a factor of 1, right? So let's just go ahead and just factor it, okay? Is there anything that we can factor out of the 9 and the 15? How about 3? If I pull out that 3, I'm left with 3x plus 5. How about across the bottom, what can I pull out? Looks like a 4, and I'm left with 3x plus 5. Do you see anything that's the same on the top as on the bottom? Yeah, that 3x plus 5. So that's our factor of 1. So now we have 3/4. That factor of 1 is 3x plus 5 over 3x plus 5. Eventually, we'll just show our work just by crossing these out or just by putting a giant 1 wherever they're at. But I'm just trying to not lose anybody. So it's a little bit extra writing, but in the end, you won't have to show me all that writing. Okay, so if that's confusing you, you can just put a slash through those 3x plus 5s and just show me that the answer is 3/4. Okay, but this is technically showing the removing a factor of 1. Go ahead and try this next one. Try to see what you could factor out of the top And then to make it match, so you get that factor of 1, pull out that same factor out of the bottom. Okay, go ahead and give that one a try. So it looks like I could pull out a -2, and I would be left with y minus 3. Now I'm trying to get that factor of 1, and I'm definitely not getting y minus 3 out of that. So I'm going to go ahead and pull out a -2. And I'm doing that so it matches the top so that I have my factor of 1. So now I have -2 times 4y, which I can break this apart so that I have -2 over -2, right? Anything over itself is just going to be 1, times that y minus 3 over 4y. So the -2 over -2 is 1. You can rewrite it with a 1 there, or you can just stick in a giant 1 like that if you want. So we can save ourselves a line. We've got y minus 3 over 4y. All right, moving right along. Oh, number 5. Look at that. What do we have on the top? Do you recognize it? Yeah, that's a difference of squares. And then the bottom, do you think you can factor that? Yeah, you can, because you got your trinomial with the leading coefficient of 1, so you can jump to the shortcut. Go ahead and try that one. And try number 6 as well. Okay, so hit pause, work on those for 5-10 minutes or so. When you think you've got them, come back and check with me and we'll compare answers. Okay, so difference of squares. That means I have a plus 3 times a minus 3. Bottom, jump to my shortcut. I can have, let's stick in my a's first. So 2 numbers that multiply to 3 but add to 4. I have positive 3 and positive 1. What is my factor of 1? That a plus 3, it's the same thing on top and bottom. If you still need to write it out to see that you're removing it and then it's a factor of 1, you totally can do that. I'm going to show you that you can also just swipe them out. Okay, so top, bottom, they match, leaving me with the final answer of a minus 3 over a plus 1. That one's done. For the next one, we have leading coefficient of 1, so I can jump to my shortcut. 2 numbers that multiply to 16 but add to 8 are positive 4 and positive 4. The bottom, we have a difference of squares, so it's going to be x plus 4 times x minus 4. And let's remove that factor of 1, so whatever matches on the top matches on the bottom, leaving us with x plus 4 over x minus 4. Awesome. Go ahead and try this one. Try number 7. Hit play when you're ready. So on this one, I think the only thing I can pull out of the top is just a 5, leaving me with x squared plus 4. And then on the bottom, I could pull out a 10, leaving me with x squared plus 4. Do you see what matches on the top and on the bottom? That x squared plus 4. So let's cross them out. That leaves me with 5 over 10. Can I reduce that? I can. 5 over 10 is 1/2. So that entire polynomial, 5x squared plus 20 over 10x squared plus 40, is really just a fancy way of saying 1/2. All right. Turn the page. Let's just do 2 more. Oh, I can squeeze them both on the same page. So go ahead and try them both. Give them a try. Hit play when you're ready. Okay, so in my first one, I'm thinking I can pull out a y, leaving me with y plus 6. On the bottom, oh, that's a leading coefficient of 2. That means I can't jump to the shortcut. Okay, so we can't do the shortcut. So what I like to do is I like to keep my equation or my simplifying. I want it to look pretty, so I'm not going to kind of get all messy over there. I'm just going to do some side work over here. And then once I factor that, I'll go ahead and write it in so it's nice and pretty. So my side work is I'm going to factor this, that bottom piece. Leading coefficient is greater than 1, so it means I have to go the long way. So I'm just rewriting so I can break apart that middle term. So I want two numbers, let's see, that multiply to, looks like 12, right? Because the 2 and the 6. So multiply to 12, but add to 13. All right, so it's going to be just 1 and 12. I'm going to put in just plus 1y just so I don't lose anybody. You don't have to have the 1 in there. It's the 12y. And now, go ahead and do factor by grouping. So these first two have a y in common with a 2y plus 1 left over. And second group has a 6 in common, leaving me with 2y plus 1. 2y's plus 1 match. That's good news. So we'll stick that out front, leaving us with y plus 6. So now I'm going to rewrite that as my denominator. So I had 2y plus 1 times y plus 6. All right, very cool. Do you see anything that cancels out? Remove our factor of 1. Same thing on the top, same thing on the bottom. Y plus 6. Okay, so that means that my final answer is just y over 2y plus 1. Don't try canceling anything with those y's, okay? Because of that addition right here, we cannot go through and do something crazy like this, okay? So if you're thinking that, stop thinking it. It's only when everything is just multiplied, like up here, where we can start canceling things out because they're factors. Okay, so we're removing a factor of 1. Down here on the bottom, it's adding, so we can't start going crazy with the canceling. Okay, it's just totally done. Leave it alone. And the last one for today. What do we have here? All right, so a lot going on. Oh, it's not too bad because we have leading coefficients of 1, right? So I can jump to my shortcut. And I threw in some b's in there, so I'm going to just throw those in right now so I don't have to think about them. All right, so two numbers that multiply to 2, but add to 3. Okay, how about 2 and 1? So I'm going to put plus 2b, and you can just do plus b or plus 1b, whatever makes more sense to you. All right, and then across the bottom, again, we can jump to our shortcut with our a's and b's. And two numbers that multiply to 3 but add to 4 are going to be 3 and 1. So plus 3b plus 1b. Do you see a factor that we can remove? Yeah, a plus 1b matches top and bottom, leaving us with a plus 2b over a plus 3b. And again, this is addition, so don't try to remove a factor of 1. Okay, so don't go like this. That's not good. That's not going to be the same answer, right? And if you don't remember why, go back, rewind, look at that first example that we were working through, those fraction rules, because we didn't get the same thing. Remember when we had something like 7 minus 5 all over 5? That really doesn't equal 7. That's the same thing that you're trying to do here if you try doing that, okay? So don't do it. All right. I think that wraps up today. Awesome job. I will see you tomorrow. Have a great day.